Lesson 8.3. Lesson 8.3. Solve systems by elimination. Solving a system by adding. The elimination method is another method used to solve a system of linear equations. In this method, one variable is eliminated by adding or subtracting the two equations of the system to obtain a single equation in one variable. The steps for this method are as follows. 1. Add or subtract the equations to eliminate one variable. 2. Solve the resulting equation for the other variable. 3. Substitute the values in either original equation to find the value of the eliminated variable.
So of course the substitution method for solving a linear system always works, but you know what? If the linear system is kind of complicated with lots of coefficients and numbers running around, sometimes solving for x or solving for y will get a little bit tricky, and you'll have fractions and things will get messy, and it'll still work, but sometimes there's actually an easier way that might be a viable alternative when, in fact, we have a complicated system. And that's called the method of elimination. Let me show you what I mean by looking at an example, and you'll see in the example why it's called elimination. Let's take a look at this system right here. So I have these two linear equations, 4x plus 3y equals 10, and x minus 3y equals negative 5. And what I'd like to do is I'd like to find the solution that satisfies both of them simultaneously. Well, I'm imagining that the x and the y that I'm going to find is going to satisfy both this one and this one. And there's something really cool. If I take this equation and this equation together, if I were to add them up, let's just look at what would happen. I'll write it down in a second, but let's just look at it together. Here I'm going to have a 4x plus an x. That's a 5x. But look what happens when I add here. I see 3y plus negative 3y. That produces 0. So in fact, I've eliminated the y. That's why it's called elimination, because I'm actually getting rid of one of the variables by using both equations together and just adding them up. And then here I just would add as well. So let's just add these two equations and see what happens. So I'm going to add the two equations. So 4x plus x is 5x. Here I've got a 3y, but now it's a minus 3y, or 3y plus negative 3y, however you want to say it. All roads lead to 0. And that equals 10 plus negative 5, or 10 minus 5, which is 5. Well, see, I've eliminated the y. That's why it's called elimination. I use both equations together. And so now I see that 5x equals 5. And so if I divide both sides by the 5, I see x equals 1. Well, that's great. Now, am I done? No, because I have to find the y value that partners up with the x. How can I do that? Well, I can do that in either of the equations I want. All I've got to do is take one of these, plug in x equals 1, and solve for y. And you can use either one. I'm going to use this one because the numbers seem a little bit smaller, and I love small numbers. So here we go. I'm going to plug in a 1 for x, and I see 1 minus 3y equals negative 5. So the first thing I'm going to do is subtract 1 from both sides. They drop out here. I'm left with negative 3y equals negative 6. I'm going to divide both sides by negative 3 to undo the multiplication. And I see y equals a negative divided by a negative is a positive. 6 divided by 3 is 2. And so I see the answer is 2. And so what's my final answer? X equals 1, y equals 2. Or if you want to write it as an ordered pair, 1, 2. And again, you can check your answer just by taking 1 for x and 2 for y in each of the equations and show that in both cases this solution satisfies both. That's the method of elimination.
All right, we're leaving it like this so we can make sure you get the entire problem in your notes. All right, and just a quick review. We eliminated the y's by adding vertically. 4x plus x is a 5x. A positive 3y when combined with a negative 3y is going to cancel out, so that goes to 0. 10 minus 5 is 5. 5x plus 0 is equal to 5x. I bring my 5 down. I want to isolate the x by itself. This says 5 times x, so I'm going to divide both sides by 5. 5 divided by 5 is 1, so I'm left with just 1x. And then 5 divided by 5 on this side is 1. Now, for step 3, I'm going to substitute this 1 back in one of the equations. It doesn't matter which one. He chose the second equation, so in place of x, we put 1. We bring down a negative 3y. We bring down a negative 5. Now, we're trying to get y by itself. It is a two-step equation, multiplication and addition, because it's a positive 1, and that says a negative 3 times y. We work backwards, so we start with addition or subtraction first. This is a positive 1. So to get rid of it, we got to say a negative 1 and a negative 1 on both sides. These will cancel out. 1 minus 1 is 0. We bring down a negative 3y. A negative 5 plus a negative 1 is a negative 6. Now we have a negative 3 times y is equal to a negative 6. We want to get the y by itself. It says multiplication, so we must divide. So a negative 3 times y. We divide by a negative 3 on this side, negative 3 on that side. A negative 3 divided by a negative 3 is a positive 1. So that's really 1y right there. And then a negative 6 divided by a negative 3 is a positive 2. So y is 2 and x is 1. Don't forget, when you write your ordered pair, x is first, y is second. X is 1 and y is 2. Okay, next we're going to solve a linear system by subtracting. If both equations contain the same x or y term, you can solve by subtracting. Example 2, of course, we always go to math on the spot first.
Okay, let's take a look at another example where we can actually use elimination as a means of actually producing from two equations, one equation with only one variable. So here I see 2x plus 5y equals 4, and together with 2x minus y equals negative 8. Now, to me, this is screaming out for elimination. I almost have to put my fingers in my ears because it's so loud, because I see a 2x and a 2x. When I see that together, that tells me that that cosmic coincidence can be used to our advantage. So instead of using a substitution method, I'm thinking elimination. Here's what I'm going to do first, though. I'm going to take my 2x plus 5y equals 4. I'm going to write it out. There's the first equation. I'm going to take the second equation, and first I'm going to multiply both sides by negative 1. So if I multiply everything through by negative 1, what do I see? Well, basically the signs are going to become sort of the opposite of what they currently are. So here I'm going to see a negative 2x. This becomes a plus y. And that equals, when I multiply this by negative 1, I see just 8. Okay, so I just took the second equation and I multiplied through by negative 1, and you can see that the signs just got flipped. Okay, but now this is perfect for elimination. Do you see why? I can now take these two equations and add them together. Look what happens. I see 2x plus negative 2x. That cancels out to be 0. So I've eliminated that. So this becomes 0, and here I see a 5y plus y, that's 6y, equals, and this is going to be 12. Well, now I can just divide both sides by 6. Isn't this great? And I see that y has to equal 2. So I know y equals 2. Now I've got to find the partner x that goes along with that y. How do I do that? You can pick either equation and plug in 2 for y and solve for x. It doesn't really matter which one you use. I'll use the second one. So if we use the second one, I see that 2x minus, and in place of y I'm putting in 2, equals negative 8. If I add 2 to both sides, what I see here is these drop out. So I see 2x equals, here I see negative 6. I divide both sides by 2 to undo the multiplication of 2, and I see that x equals negative 3. And so I see the answer is x equals negative 3, y equals 2, or if you want to write it as a pair, you could write it as negative 3, comma 2. And again, you can always check by plugging these values in for x and y into both equations and see that both equations, in fact, are satisfied. So elimination is great when you see some kind of cosmic coefficient conspiracy.
Okay, now let's take a second look for those of us who might be confused. Remember now, you write everything out like so. Make sure the x's are lined up, make sure the y's are lined up, equal sign is lined up, and the constant is lined up. Now you realize that these two numbers are the same, 2x and 2x. These two numbers are the same. So if one were negative, that means they would cancel out. So if I made this opposite, so right now it's a positive 2x. If I make it a negative 2x, I'm making it the opposite. That means everything else on this line has to become the opposite. The way you do that is to multiply the bottom equation through by a negative. So a -1, there's really a 1 sitting right there that you don't see. A -1 times 2x is a -2x. A negative times a negative is a positive. And a negative times a negative is a positive. So the y becomes a positive y, and the -8 becomes a positive 8. The positive 2x there becomes a -2x. Now we can add the equations to eliminate the x terms. So now 2x plus a -2x is 0, or you can just say 2x minus 2x. That's going to be 0, so that's gone. Now adding going down, we got 5y plus 1y. That's going to be 6y's. 4 plus 8 is 12. Now I'm back to a one-step equation involving multiplication. What's the opposite of multiplication? Division. So I'm going to divide both sides by 6 to get this y by itself. So divide by 6, divide by 6. 6 divided by 6 is 1. So I'm left with just 1y. Remember, there's no need to write the 1 there because how many y's do you see? Just 1. Now 12 divided by 6 is 2. So y is equal to 2. Now I take this y value and I can plug it into my top equation or my bottom equation. My rule is you plug it into the one that looks the easiest to work. Now to me the easy one to work is the top equation. But he chose to use the bottom one. Doesn't matter. Answer should work out to be the same. So we work with the bottom equation. So we got 2x minus y is equal to a -8. So in place of y, I'm going to put 2. In place of y, I'm going to put 2. So I got 2 times x minus y, so that's going to be minus 2, is equal to a -8. Now I'm solving a two-step equation that involves multiplication and subtraction. So we always start with the multiplication. We always start with the addition and subtraction first. So since it says a -2, I must add a positive 2 to both sides. A -2 when combined with a positive 2, that goes to 0, so that cancels out. I bring down my 2x. Go to the other side, and -8 plus 2 is a -6. So now I have 2x is equal to a -6. This is a one-step equation involving multiplication. What's the opposite or the inverse of multiplication? Division. So I divide both sides by 2. 2 divided by 2 is 1. I'm left with just 1x. There's no need to write that 1 there. A -6 divided by 2 is a -3. So x is equal to a -3. So my final solution is x is a -3 and y is 2.